All right, so picking up on number 26. So we have a motor on a rocket fails if one or more of the three fail-safe fuses blow before ignition. The probability of any single fuse blowing is 0.15. So I'll do the probability of B is 0.15. They want to know the probability that the rocket will launch. Well, think about this logically. Okay, the rocket fails if one or more blows. So if none of them blow, so if x equals 0, it's going to launch. So this goes back to our discrete distributions unit. This is a binomial distribution. The reason why it's binomial is because they let us assume the fuses act independently of each other. And we have two independent events, right? You either have a fuse failing or not failing. So I can use a binom PDF. When you have exactly a value, that's a binom PDF. Remember, first you plug in the number of trials. Well, there's 3 fuses for this rocket. Then you have your probability of success, which I know doesn't seem like success, but the probability of a fuse blowing is 0.15. And then you have X, how many you want to blow in this case. Well, we want none of them to blow. Otherwise, the rocket won't launch. So remember, the way to get to binom PDF is you hit second and then bars for distribution. I'm going to go to binom PDF, which is letter A. Mine actually asks me the trials, the probability of success, and the X value, but yours may not. Your calculator may just say binom PDF, open parentheses. So I would do 3, comma, remember comma is above 7, 0.15, comma 0. So that's how I get 0.614. So letter B. All right, the next one. A teacher will consider curving test scores when more than a quarter of the class fails the test. The probability of a random student failing is 0.21, so the probability of failing is 0.21. And they want to know what's the probability of a class of 32 students the teacher will decide to curve the test. So once again, they consider curving the test when more than a quarter of the class. So first, let's find a quarter of the class. So a quarter of 32, well, that's 8 students. But they just want more than that. So not exactly 8 students, that's still okay for them. But if I have the probability that X is greater than 8, then they will curve the test. So if you guys think about this, and I list out all the number of students possible for a class of 32, I'm going to stop there since I'll run out of room anyways. Think about more than 8. That means you want 9 or more students to fail. Okay, so if I get that, that means I'm going to do a 1 minus binom CDF. Remember, if it's more than or equal to, you find out what you want, which is going to be greater than. But the problem is a CDF only handles 0 to that number that you specify. So I'm going to do 1 minus the CDF, and I'm going to get rid of, so I know there's 32 students in the class. The probability of failing is 0.21, but the last number I'm going to get rid of, like all these numbers I want to get rid of, so the last number I want to get rid of is 8. So if I do that, I have 1 minus binom CDF of 32, comma 0.21, comma 8. And that's how I get 0.215. The tricky part about this, though, that you guys have to be super careful about is that it's more than 8. If it was more than or equal to 8, we'd handle that a little bit differently with that last number. So always pay attention whether or not you can include that last digit or not. Okay, so the next one, we have 3 questions about the Chocolati Candies Company makes candy-coated chocolates. 40% of the chocolates are red. So the probability of red is 0.4. The production line mixes the candies randomly and packages 10 chocolates per box. So for 28, they want to know what is the probability that less than 4 candies in a randomly selected box are red. So less than 4. So I want the probability that X is less than 4. This is still binomial, like 26 and 27. You either have candies that are red or not read. Okay, so to get less than, that is exactly the definition of a binom CDF, is less than. But once again, it didn't say less than or equal to 4. So when I list this out, I need you guys to realize that less than 4 would be 0 to 3. So out of 10 chocolates per box, the probability of getting read is 0.4, and I want 0 to 3. So typing that in, second vars, binom CDF of 10, 0.4, 3. That's how I get 0.382. Letter A. Okay, let's keep going with that. 29. What is the probability that at least 5 candies in a randomly selected box are read? So at least 5 means X is greater than or equal to 5. When you come to words like at least and at most, think about money. If you need at least $5, you need $5 or more. Okay? This is very similar to 27, but this time we can equal the 5. So if you guys think about this, once again, I like showing you this visual. If I want 5 or more, that means 5 can be included. So once again, a CDF only handles 0 through a number. So if it's more than or equal to, I'm going to do 1 minus binom CDF. There's 10 chocolates in the box, 0.4 are read, and I want to get rid of, so the last number I want to get rid of is 4. That's the last number that wasn't in our box. So 1 minus binom CDF of 10 candies, 0.4 are read, and the last number I want to get rid of is 4. So that's how I get 0.367. Letter C. Okay, let's do one more. And then we'll see where our time's at. So, number 30. Which of the following are valid methods to calculate the probability of having at least 3 red candies? So at least 3 red. So I want the probability that X is greater than or equal to 3. Once again, since it's greater than, I'm definitely going to use a CDF, and it's going to be a 1 minus CDF. So B is definitely, well, I shouldn't say definitely out because I just noticed they changed that to 0.6. So it's actually C. Okay, so traditionally the way I'd solve this is 1 minus a binom CDF. There's 10 chocolates out of 0.4. Once again, if you think about your chocolates listed out, if I want 3 or more, the last number I want to get rid of is 2. So that's exactly what A said. Okay. The reason why B may work is because notice how it says binom CDF of 10.6, 7. Well, 0.6 is that they're not read. So if you want at least 3 read, wouldn't that be the same thing as having 7 or less not read? So that actually works as well. And even though this isn't the most traditional way to do it, if you subtract 3 separate PDFs, 0, 1, and 2, that means exactly 0, exactly 1, exactly 2, and that's what you're subtracting out from 1, that'd be the same thing as letter A. So this is actually letter D. That's kind of a tough question if you ask me to go through that, but I guess it's a good way to think about it because you could always think about not read. So let's see, we have 1 more minute. I'll just go ahead and stop this video and pick back up because this is for the next 3 questions. So that way it's all consistent. So I will see you guys in the next video.